Welcome to the project demonstration of applying wireless sensor network for power monitoring system. So here we are using wireless technology like 2.4 gigahertz operated Zigbee module, and the data will be sent from this energy meter section and to this receiver section, and the data will be monitored on the laptop. So like this, the power units continuously for every 1 second the data will be sent to the section of the receiver module. And here we are using current sensor inside this energy meter, which will calculate the kWh pulses, and that pulses will be given as input to the PIC16F72 microcontroller through this PC817 optocoupler. So here the purpose of the optocoupler is, so we are going to calculate the number of blinks from this LED. So though LED get the DC only, so if we give that DC output from the LED directly to the microcontroller, if any damage occurred inside this energy meter, in that case, then the directly AC voltage passing all over through this port, then the same 230 volts AC will be given as input to the microcontroller through this LED connections. Then there is a chance of microcontroller damage. So in order to prevent that damage, we place the optocoupler as a mediator between the LED and to the PIC microcontroller. So if any like short circuit occur inside that, only this optocoupler PC817 will get damaged. So we can replace easily the small IC. So we have interfaced that pulse input to the A4 pin of our microcontroller. So here the calculation of kWh readings will be achieved based on the calculation of 3200 impressions. When this count completes, then the controller will indicate as a 1 kilowatt hour was completed. So why? Because that 3200 impressions per kilowatt hour was already the data sheet mentioned from this current sensor which we are using inside this energy meter. So based on the energy meters, the different count will be there. Some has a 6400, some has a 1600. So but what the model we are going to use in our project is, will provide us a 3200 impressions per kilowatt hour. So the controller keep on counting that. Once the count is reaches 1, then 1 by 3200 kilowatt hour. So when the count increases, then the kilowatt hour also increases. So the so-called status continuously displayed on the LCD screen. We have interfaced that to pin number B2 to B7, and the same data will be passed through the receiver section to the department to the Zigbee technology. And here the Zigbee transceiver we are going to use, which was interfaced with the B0 B1, and the same data will be received by the Zigbee module, and that will be passed through this USB to TTL converter, and that will be displayed on the hyperterminal application in our laptop. So before demonstration, first of all we need to install the applications. Okay, that is PL2303 application initially. So install that. So once you successfully installed, then it will ask you to insert that, and insert it now to any one of the USBs of your laptop. And after that, continue. At the end, it will ask you to restart the laptop. Don't restart it. Select no. Finish. So after that, go to this PC, right click on that, may show more options, manage, then go to device manager, so in that device manager, and then check with the ports. So the ports will show you the communication number of our USB to TTL converter. Here we get that. So if it shows like contact your supplier or dealer, the error, instead of showing the COM number, then right click on that, update driver. If it shows the error, then only do these steps. My computer, let me pick from the list, and then you need to select the 2008 version. Then it will show you the 2008 version, because this particular PL230 the driver automatically updates when you connect the laptop to the internet. So then the update driver also will be show here 2023 or 21. Then we need to select the 2008 version. Click on next. Okay. When you get that error. So as of now, no error, and now we got the COM number is COM7, right? So note on that. Now go to the hyperterminal application folder. There, click on this, and now type any character, first name, any name, and then COM7. Okay, and next restore defaults, and now okay. So now the system got connected. and now on the power supply to the case. So we are providing 230 volts AC input to this regulated power supply board, and from here we are distributing that 5 volts to the motherboard, and parallelly same 230 volts input to the energy meter, and output of the energy meter is connected to the 230 volts load. Here using 200 watts bulb, so for faster reading purpose. So this regulated power supply board consists of 4 stages, and transformation, rectification, filtration, regulation. After these 4 steps we will get the 5 volts DC output. Just on that. So after switch on that, don't touch anywhere on this one. The 230 volts passes all over the board. You can see that the reading is incrementing now. Okay. It's better to keep the more distance between the energy meter section and the Zigbee module, as it can support up to half kilometer of distance, means 500 meters of distance we can get the data on your laptop. Right. So here one more thing is, like, whenever we are sending the data from this energy meter section, we can see one light should blink on this USB to TL module. So that will show the status of data is arriving at this section. If it's not blinks, just off the system and on it again, then you will get that.